Dear students, how are you doing? Hope you are fine. Students, don't forget using mask, keeping social distance, keep your personal hygiene, especially wash your hand frequently. Those are the prevention of COVID-19. Now let us proceed our topic 3, which is argument and validity. In topic 2, we have seen what does mean open statement and quantifiers means. In this topic, we will define argument and we will check the validity of a given argument. First, let us see the definition. As you see here, an argument is an assertion on that a given set of statements P1, P2, P3 up to Pn called hypothesis or premises gives another statement Q called the conclusion. Such a logical deduction is denoted by like this. Now here we may use a different number of statements. Here we may have P1, P2, P3 up to Pn. This shows after this symbol we put the conclusion 1. This is one of the method which denoted logical deduction. The another one, P1, P2, extra up to Pn. And here we have a bar, and lastly we'll put the conclusion. Here P1 may be a single statement or a compound statement. P1 may be also P2 is like that. So an argument is a prepositional logic is a sequence of prepositions, all but the final preposition in the argument are called premises and the final preposition is called conclusion. For example, look this. If you have a current password, then you can log on to the network. By the way, students, do you remember a logical connector or a logical operator, which you call it implication? If, then. So this is if you have a current password, then you can log on to the network. This is the first P1. Like this. This is the first P1. As I said before, it may be what? A compound or a single statement. So the second premises is, or hypothesis, you have a current password. So this is another P2. Therefore, you can log on to the network. Now, this is an argument form in words. So these are premises and these are conclusion. By the way, we can identify the conclusion easily after a statement which comes next after the word therefore, so, like that, they are called conclusion. And a statement comes before therefore or so are premises. Now, the next our task is represent that verbal argument form to a symbolical or mathematical form. An argument is a prepositional logic, is a sequence of compound preposition involving prepositional variables. So, in last, we have seen if you have a current password, then you can log onto the network. If P, then. So, you have a current password is P, let's say this is P, and you can log on to the network. This is Q. And the second one, by the way, this is the first premises. we call it P1. P1. And the second P2 is you have a current password. Already we denote this. A current password is is P. Is P. Therefore, you can log on to the network. I think you can log on to the network is Q. Q. So the first one is P implies Q. This one is P1. Don't say this is it have two statements. Now we have to consider as a P1, capital P1, capital P1. And you have a current password, another what? Another statement. And you can log onto the network. We use a bar here, therefore Q. Now, P implies Q is P1, capital P1, P, capital P2. If we may have another, capital P3, capital P4, we are continuing up to PN. But the last one is called conclusion. This is capital Q, capital Q. So P implies Q, P are hypothesis or premises. These are what? These are what? Conclusion. A conclusion. So, based on the conclusion, we can divide argument is valid and invalid argument. When you say valid argument and invalid argument, valid argument in propositional logic, an argument is valid if the truth of all its premises implies that the conclusion is true. Students, don't forget that premises or hypotheses are considered as always true. Bear in mind, I will repeat it. Hypothesis or premises considered as always true. So, our next task is identify or finding the truth value of the conclusion. After finding the truth value of the conclusion, if we get true, means if we have a true conclusion, the argument is called valid argument. Otherwise, if you get a false conclusion, the argument is called invalid argument. And there are so many methods to check a given argument is either valid or invalid. In this presentation, we will see some of, but you have to refer. There are different methods. So, the first method, for example, the argument is valid if we get a tautology. What does it mean, tautology? A tautology means after you constructing a truth table, if a compound statements have a true value for all possible combination, we call it that is a tautology. A tautology. Tautology. Here, if a given compound statement is tautology, we can conclude that that argument is valid argument, but it must be put like this: P1 and P2 and P3 and Pn implies the conclusion one. If it is tautology, simply we can say the given argument is valid argument. Valid argument. Valid argument. So we can use a truth table to show that an argument form is valid by showing that whenever the premises are true, the conclusion must also be true. Don't forget, premises are always true. Premises are always true. Always true. For example, let us check this one. P implies Q, P, therefore Q. So the different color Q is conclusion. Now, as I told you, there are two letters here. P, Q to the power of 2 is 4, false, false, true, true, false, true, false, true, as usual. So P implies Q is obviously false implies false is true. Simply we get false only when Q is false. So combine this and this by AND. P implies this. We get this one. Lastly, like this. P and P implies negation, Q. So this is a tautology. This is a tautology. So we can say this is what? This is a valid argument. Or rather than doing this part, we have another method. Let me show you. We know that P implies Q with premises means it is true. P, it is true. So select a row when P implies Q is true, at the same time P is true. Look here. P implies Q is true here. What about here? What about P? False. Oh, so this row is not important. Not important. Okay, another. This is true. Okay, what about P? Oh, this is false. So this row is also not important. First row and second row are not important. What about this? Oh, it is not important because P implies Q is, we know that premises are true, but it is false. Okay, what is here? Okay, P implies Q is true. Yes. What about P? It's true. Yes. This is important row. Important row. And lastly, visualize the truth value of the conclusion. What is the conclusion? Q. What is this? True. Oh, bingo. This is valid argument. It is enough, by the way. It's enough. So this is a valid argument. But if this was false, the argument will be an invalid argument. Invalid argument. Invalid argument. But I don't prefer to use a truth table because, look this, we can use a truth table to show that an argument form is valid or invalid by showing that whenever the premises are true, the conclusion must also be true. But if an argument form involves different type of prepositional or statements, for example, if you may have 3 to the power of 3, 8 lines or 8 rows, it may be handled. To the power of 10, look this, these rows are needed. This is a tedious and long and boring approach. Long and boring approach. We may use an argument which involves 3, 4, 5, even to the power of 5, 32. So that is. So there are different kind of approach or different methods to identify the given argument is valid and invalid. Let us, in this presentation, let us see this rule of inference or detachment rule. And instead of using a truth table to show that an argument form is valid, we can use rule of inference. Now, the tautology is the base of the rule of inference called modus 1 or law of detachment mode that affirms. Here we have seen last one. The hypotheses are written in a column. These are columns. The first column, the second column, followed by horizontal bar. The bar is color, followed by therefore and the conclusion. By the way, do you remember therefore? This is a symbol of therefore. Therefore. So the general form of rule of inference or detachment rule is you have to put hypothesis up, hypothesis 2, let's continue, hypothesis 3, hypothesis 4, up to hypothesis n. Lastly, we'll have a conclusion. This means, by the way, therefore. This means therefore. Well, by the way, let me tell you one thing. When I teach university on Thursday, on Sunday, our dinner was therefore. What does it mean, students? Our dinner was therefore. At that time, our dinner is meat, but there are some amount of what meat, like 3 meats. So ordinary is today is therefore, today is therefore. Now that comes, I think, from here, from here. So there are two type of forms, this form and this form. We can use interchangeably. They are the same. They are the same. Now let us brief this topic by examples. Examples. Let us investigate the validity of this A, B, T. A, it says P implies Q, comma, negation Q, and negation P. Now negation P is here, the conclusion, but these are the premises. I will show you the solution of A, and I left to you for B and C and the others. Solution. I will show you using two methods. First, we construct a truth value or a truth table for the given statement, the given argument. By the way, is this tautology? It is tautology? No, it is not a tautology. So, is it invalid or valid? If an argument or if a compound statement is tautology, it is guaranteed to be valid. But it does not mean that if it is not tautology, it is not valid. It does not mean that. It may be valid. It may be valid. For example, now let us take an important what? Rows. P implies Q and negation Q. Okay, P implies Q true, negation Q here is false. Oh, this is not important, or the second also not important. Why I say not important? Because I will take the true value, because premises are always true. What about this? This is true, this is false, therefore this is not important. What about this is true, this is true? Okay, this is important row. And then what is the conclusion? Negation P. Okay, it's true. What is P? Oh, P is false. So, can I say it's invalid? No, because here the conclusion is negation P and P is false. The negation of false is what? True. So our conclusion is true. So this is valid argument. And let me show you by rule of law of detachment. Now, P implies Q is true because this premises. And or let me show you, P implies Q true because of premises. This is also true because of what? Premises. Now let's proceed. Negation Q is also true because 1 and 2 are. Because what? They are premises. So if negation Q is true, what will be Q? Negation rule. Q will be false. Then from 1 we have what? P implies Q is true. Don't forget. P implies Q is true. Don't forget. And from 3, Q is false. So P implies false is true. Now we have to recall it. Truth table of implication. When we get a truth value, for example, let us take P is true. True implies false. False. So P can't be true. So false implies false. True. Bingo. P is false. What is our objective, my student, here? From question A, check the truth value of negation P. So from here, P is false. What will be negation of P? True. Therefore, our argument is valid argument. You can use like this. So, you can observe this solution B. What already I did it, so read and understand it. Students, here is activity 1.3. It helps us to understand topic 3. Topic 3. Therefore, please read it and do it. Do it. Do it. My student, the next one is topic 4. It says that set theory. I think you are familiar for about sets, starting from grade 7, 8, 9, 10, and others. So this part is not familiar. I mean, this part is familiar to you. Familiar to you. So up to this, we follow or we are approaching a teacher-centered method. So next the topic 4 covered by student-centered method, and I will give you an assignment which is covered by like this. My students, prepare a short note about set theory. Means you have to define with examples about a point or a concept which is around a set theory. By the way, your page not more than 20 page, and submit to by this email. Thank you. Questions? If you have questions and suggestions, put your comment in this email address and uses a Telegram channel. Thank you very much to follow this chapter. This is the end of chapter 1. Thank you very much. Thank you. See you again in chapter 2.